Welcome back to Structural Basic USA. So far in this series, we've learned how to convert PSF into PLF. And we've learned how tributary width determines the load received by a beam. But before we can calculate a beam load, there's one more question we need to answer. What load are we actually using? Imagine two beams. They have the same span, the same size, and the same tributary width. One beam passes, the other fails. Why? Because the loads are different. In structural design, loads control everything: the beam load, the bending moment, the shear force, the deflection, and ultimately, the beam size you choose. The three most common loads you'll encounter are dead load, live load, and snow load. Let's start with dead load. Dead load is the weight that is always there. Roof sheathing, framing members, drywall, roofing materials. These components don't move, they're part of the structure. That's why we call it dead load. For many residential wood-framed buildings, roof dead loads often fall between 15 and 25 pounds per square foot. But the actual value depends on the materials used in the project. And here's an important design concept. Reducing dead load doesn't just reduce gravity loads. It can also reduce lateral forces from wind and earthquakes. That's one reason residential structures often use lightweight materials whenever practical. Less weight, smaller lateral forces, and potentially lower construction costs. As engineers, we don't just calculate loads. We also think about how design choices affect those loads. Now let's look at live load. Unlike dead load, live load can appear and disappear. People walking, furniture, storage. These loads are temporary. They're not always present. For a typical residential living area, a common live load is 40 pounds per square foot, and that value comes directly from the building code. In the United States, required live loads are specified by the building code. That's why it's important to verify the required live load for every project. Roofs can also have live load. This is called roof live load. For many residential projects, roof live load often starts at 20 pounds per square foot. However, the actual design requirements should always be verified using the applicable code. Now let's talk about snow load. Snow load is different because it depends heavily on location. Some projects may have very little snow. Others may have enough snow to completely control the design. Ground snow loads are obtained from ASCE 7 snow maps. That's why two identical houses can require very different designs in different parts of the country. In some regions, snow loads may be 20 pounds per square foot, 30 pounds per square foot, or significantly higher. Let's compare them. Dead load, permanent weight. Live load, temporary weight. Snow load, environmental weight. One common mistake beginners make is assuming every roof uses the same loads. That's not true. Loads depend on the project, the building use, the location, and the applicable code requirements. Good engineers don't guess loads. They determine them based on the code, the building use, and the project conditions. Because every calculation starts with the correct load. So here's the key takeaway. Before calculating a beam, you must first identify the correct loads. No load, no beam design. Now we have everything we need. We understand PSF, we understand tributary width, and we understand structural loads. In the next video, we'll combine all three. We'll take a real roof load, a real tributary width, and calculate the actual load acting on a beam. That's where beam design really begins. See you in the next video.